Appreciate the opportunity to speak with you today about artificial intelligence. It certainly is a burgeoning topic, and will continue to get larger and larger with the exponential growth, especially in our computational capabilities. Tonight, really, though, is talking about you and AI, and I'm going to really speak a lot about the foundational issues about how AI works, but really want to get into how you can best leverage it. And I think probably the best way to do that is to show you the details about what underlies the technology. And I think what that will do is excite your creativity and your imagination. You'll be able to see patterns in data, patterns in how these tools develop. I'll show you kind of the latest developments and where I see this technology advancing in the near term and the long term. If I can cut to the chase and show you something, it's this slide. So if you look on the left of your screen, essentially it's your brain. And when I grew up in Iowa, I had a library card. That pretty much was my access to information. Right now, of course, we have computers and we've got cell phones. And in many respects, we're building almost these external brains that we can access. And these brains are getting larger and larger and larger, of course. The challenge becomes, how we access this data. There's so much data coming at us. One of the exciting things about artificial intelligence is its capability to help sift through that data and help act essentially in certain ways to work through that data and do things with that data on our behalf. So I'm going to talk about how almost we start to build this external brain. And you're already building this yourselves with both the apps that you're utilizing, some of the chat GPT and other tools that you're using. And so as we go forward into the future, I think this will be very important for each of us personally as well as business-wise, is building this external brain, the security around this external brain that we're utilizing, and then making sure that it's the most powerful, best information and so forth that we can access so that we can do various things with it. So what I'm going to do with this presentation, I'm going to show you the foundations of AI, which really is information. And I'm going to go very deep if you want to go deep, and I hope you want to go deep. Then I'm going to show you how AI works, just generally how it works, if you're not familiar with it. Then I'm going to talk about what it currently does, where it's going, where I think the next big thing is, which is agents. I'm going to talk about agentic reasoning and agents. I'm going to give you a practical example, which is how we're using artificial intelligence in environmental work, and then talk last about some own ideas about how you can develop AI solutions similar to the ones that I've been working on for the last 7 years. The foundations of AI, I hope all of you want to go deep. I'm not suggesting that this world is a matrix, but we're going to go deep if you want to in terms of how information works, because it will give you an idea about the power of artificial intelligence, both now and into the future. So we're going to go down this rabbit hole together. So this was Niels Bohr, who back in the early part of the last century was looking at the quantum effects and had this idea essentially that there was much more behind what was happening in our classical world. This essentially is what's happening. It's very odd, but underneath essentially the matter and energy of this world essentially is information. Probably you recognize a lot of people in this picture. This was the Solvay conference, and you'll see Einstein and Madame Curie and essentially a bunch of the greats that, of course, won plenty of awards through the years. They got together at the Solvay conference to discuss a weird phenomena, that of quantum physics. What they wrestled with essentially was this, and this really gets behind information. And I'm going to show you how information works. If you've never seen this experiment before, this is probably the most famous experiment in science. What essentially is being done in this clip that you're seeing is that we're shooting photons through two slits. And when that happens, what you would think you would see on the back would be two slits of information, but we don't. We see essentially this interference pattern. And anytime scientists see an interference pattern, they know that it's a wave. So from this, we understand that light is a wave, but what's happening on the back, you can see it's not coming out smudged like a wave. It's arriving in discrete packets, like a particle. So from this, what scientists realize is that light or electrons. Everything essentially is both a wave as well as a particle. And once it's observed or measured, and we aren't going to go down there, we don't know exactly what a measurement or observation is, but at that point, essentially, things become more wave-ish or particle-like. Before that, essentially, everything is information, or everything is a probability wave function. So there's another way of seeing the wave. The wave is coming through those slits essentially as information, probability. And then once it's being observed, then it's becoming bits or matter or other information, of course, that you and I observe and measure and use in our daily lives. So the classical digital computers, after it's gone through essentially, right, that probability wave function, it's making that 0 or 1. Which is very interesting. All of this universe essentially that's creating because of logic gates and that simple yes-no determination that's essentially happening. And below that is quantum computing or qubits in the quantum world. And probably all of you have heard about quantum computing, which eventually will be here at commercial scale. But qubits essentially is holding things in essentially that position where it's both a 0 or 1 at the same time. And so that ability to utilize computation at that level is where we're going as well, which is extremely exciting. As excited as all of us are about artificial intelligence, once we get to commercial quantum computing, it will be at least twice as much, probably even more. Quantum computing has the capability of actually impacting our lives more than artificial intelligence, I would argue. So here's a picture of an early quantum computer. But everything essentially underneath the surface is data. So classical data, you can see here, I put binary data, 0s, 1s, we'll talk about that. Biological data, it's all just 4 amino acids. Everything that is alive essentially is those same amino acids. It's just a code, ACTG. Human language, we'll talk about that, but the alphabet is 26 letters. Again, all of it can be reduced to bits. I always love this chart because it helps me think of everything essentially at one level as digital information. So if we wanted to represent a tree, it's just a longer list of 0s or 1s. Music, 0s or 1s. Humans are about 6 million bits of information. I'm going to leave out sentience and consciousness, but the other aspects are represented by about 6 million bits. Math, the universe, if you want to take it out to that scale. So the famous physicist John Wheeler, who Princeton came up with the term black hole, which you probably have heard of, came up with another expression of it from bit, essentially that matter and energy and so forth comes from information based on kind of the information that I was showing you. So billion, I was off on the amount of bits for a human being, but again, even my arm, this arm that you're looking at, or you can look at your own arm, all of it is new over the last 10 years, essentially. We're more information that makes matter rather than matter that makes information. So all these cells have been replaced and so forth over the last 10 years. Most of our body is replaced every 10 years. So it's just fascinating to think about what's happening at a different level than our senses provide us. But all this is helpful with understanding how information works in the universe, how we can both leverage it and leverage it through artificial intelligence. So essentially, the universe is doing this. Probably all of you are familiar with the laws of science. The amount of information is the same in the universe as it was when the universe began back 13.8 billion years ago, but the number of computations have increased. So matter was condensed when we started out 13.8 billion years ago, and since that time, essentially the computations have increased to the point now that I can talk to you. You can talk to me, and we can have this video conference now, which is just extremely exciting how small little computations have occurred trillions and trillions of times and resulted in all this beautiful complexity around us. So MIT has done a calculation of the amount of bits in the universe. It's about 10 to the 90th bits in the universe. Humans have generated about 10 to the 21st bits. So a lot less bits, and then or 10 to the 45th, and about 10 to the 21st is what we've trained some of these large language models on. So as computation continues to increase and we can train more of the artificial intelligence to understand those bits, the computational capabilities of eventually arising to the size of certainly Earth as well as the universe become into the realm of possibility, which is tremendously exciting. This is a picture of NVIDIA. If you're familiar with Earth 2, NVIDIA is developing a digital twin. If any of you have heard of digital twin technology, this is NVIDIA's, and I think they're about 10 to the 23rd bits in terms of what they're able to simulate, and they're down to about a 1 kilometer simulation of Earth. So Earth is very simple. I think all of you probably have seen this equation. Simple equations, simple algorithms that's just been written, done over and over for billions of years. Yes, no decisions, and resulted in the complexity around us. Alan Turing, probably all of you are familiar with that, with him who came up with the universal computer or some of the ideas behind it. Really, he borrowed a lot about from this woman. And I just because it's such a great story in computer history, I want to tell it. But Ada Lovelace was the only legitimate daughter or progeny of Lord Byron, the fiery poet from that time period, who was running around smashing looms. And his daughter saw the loom, and instead of seeing it as something that was going to take weavers' jobs away, Ada saw it as a computational tool, which it was. So the Jacques loom was one of the first analog computers in the world. So when you think of it, those punch cards essentially are just computers. It's a computer. And so she had that idea and actually became the first software engineer in the world. So I don't think a lot of people realize that about Ada Lovelace and her contribution. She also came up with the idea of the universal computer. She was a harpist, and I'm a music fan, and she really thought that eventually that these computers would be able to simulate and create music. So interesting that she was right. I'm going to talk about one other thing because it's really key to understanding information and AI and where this is going is entropy. A couple big movements that happened along with computation was the science side and the mathematics side. And so two people that I wanted to talk about was Maxwell and really the father of the digital age, Claude Shannon. If you have not heard about Claude Shannon, he should be, I think, more popular and known than Einstein. He's not, but his contribution, I would argue, to the modern world is at the same level as relativity. So if you've not learned about that man, I'm going to talk about him. But his mathematical theory of computation, which came out in the mid to late 1950s, created the term bit. Essentially learned how to measure the size of information and realized really the power of information and its essentially universality. So anyway, really encourage you to dig into who Claude Shannon was. But I'm going to talk about, again, the science, the mathematics side, and then we're going to dive into artificial intelligence. But this will help with your understanding. So Maxwell, of course, working on the laws of a lot to deal with light, came up with this thing, this thought experiment called Maxwell's Demon. And what he realized is that if you see that room on the left, you're seeing fast electrons, which means it's a warmer room. So anything that's warm just means it has electrons that are jiggling more. On the other side, essentially, is a colder room, electrons jiggling slower. What Maxwell realized is that just by utilizing information and controlling that gate, he could essentially, the laws of physics supported that we could just move the fast ones over to the slow ones, or take the slow ones and move it over to the slow ones, just using information, which is completely true and proven. It seems crazy, but it's possible. What he thought, though, is that how did this work with entropy? What we realized, though, is that by doing that, we don't get a perpetual machine that we can always get cheap and free energy. Actually, there's energy that's being lost here, and entropy is increasing because essentially there has to be an erasure of that data. We're not going to go into all the details, but think about this experiment sometime, because we still don't completely understand it, but it's showing that there's a significant relationship between information and energy and matter. And I think what our future is pretending to is that as we're able to use these information technologies better, our ability to control energy and matter is just going to increase. So it's an extremely exciting, I think, way in which we seem to be moving. Just a note about Claude Shannon and entropy. He borrowed the idea of entropy and realized that information has that entropy. Probably all of us are familiar with compact discs, or the idea of zipping a file. And what that does is essentially take that data and find all the redundancies in that data and remove some of those redundancies. Even as I speak to you now, probably half of the words that I'm using don't have any information associated with it. They're called essentially throwaway words. In fact, in artificial intelligence, we generally throw them away, like words like the, and so forth. All those words get thrown away because they don't carry much information with them. And so Shannon was able to measure the amount of information or surprise in language. And because of his essentially development and contribution, we came up with the term bit, which is the smallest bit of information essentially before we get into the quantum realm. And so that's what AI essentially is working with. What's interesting about intelligence in life is it seems to be almost anti-entropic. It seems like almost life in the universe and intelligence organize information in such a way as to fly in the face of entropy. And entropy is not our friend. Eventually, things move from order to disorder. And so without really life, without intelligence going in the opposite direction, we're not in good shape. So I would argue that more life is the key to the universe and more intelligence. So that background to say, I hope that got you extremely excited about information, AI, and how this is developing. Clearly in our brains, we're doing those kind of calculations, but now, of course, we're beginning to do those kind of calculations and computations using artificial means, silica, and so forth. So how does AI work? It's really understanding and manipulating all these bits. Remember, I'm going to go way back here and just show you, you and I look at language and music and trees and the universe different. AI doesn't. And it's almost a beautiful thing. It's just looking at zeros and ones. Isn't that amazing? So when people think, why is it seeing some pattern in music and it's associating that pattern with something in biology? Well, it's because it's seeing just zeros and ones. And so its ability to see across data silos and see connected patterns is giving us all kinds of new possibilities. I spoke with one of my doctor friends when we were on vacation a couple months ago, and he said, Jed, it's very strange. We're now looking at medical images of the retina, and we're able to detect things regarding insulin levels and all kinds of things, but all these kind of relationships that we're just not able to see because AI is looking at just bits of data. It's seeing past those silos that you and I might have sometimes problems being able to see across. So it's just interesting. I wanted to go back and show you kind of a little bit about how that was working. So it's looking at essentially all those bits of data and looking for relationships in that data. Certainly, it's going to be more important than fire or electricity. How it works and why it's so different than how we've typically used computers. In the back, of course, with traditional programming, we're putting in data, we're putting the rules, and then it's coming up with the answer. Here is completely different. We're giving it the answers. We're saying, here's the data, and it's essentially coming up with the rule. And once it has the rule, it can apply it in ways, right, that make connections that we simply can't. When I first saw AI and I saw how it worked, I went, this can't be as simple as it is, but it really is. And I'm going to show you, this might be one of the most important parts of the discussion, but I'm going to show you how this works. So, and I'm going to do it through just showing you an image, but you'll see how simple AI is. So you can see I'm putting in this picture of George Washington, and here's the pixels. And so every picture, of course, has just sometimes millions of pixels. So they're black, white, gray. So all of those have percentages associated with them, right? Right. This image might be 25% black, 45% white, and so forth. All these images are located at different parts of this picture. They also have different parts that are cut off or not cut off. And so what we can do is begin to see the relationships between those pixels and begin to create this neural network that understands the relationship of essentially these components. This hidden layer here is nothing else except for an ability to calculate probabilities. And so it's calculating the probabilities of those different combinations of features and then predicting what might be essentially, is this George Washington or not? When it's not, and it won't be, and you don't want it to be, you want it to be almost wrong, it back propagates. And when it back propagates, the only thing it does essentially is readjust this probability distribution. So if I've reduced the fact that it's not, and it's 50% essentially less chance that it goes here, the only thing I'm doing now is that I'm working with 50% less probability than what I had last time. So I guess again, and then when I'm wrong, back propagate again. Now I'm only dealing with 25%. Then I go through the whole analysis again, back propagate. So think about this essentially going over billions and billions of times, now essentially almost at light speed, and you've got artificial intelligence. Very strange, isn't it? How simple it works. And this essentially this transformer or deep learning neural network that was created, this architecture, came up with the idea that originally when we started out with artificial intelligence in the 1950s, we were thinking that we could program computers with logic. And they realized that's not how the human brain is working. We aren't logical. We're essentially working with probability. We have these neurons that are firing and making connections, so that I'm looking at you right now and I can't tell if it's 100% you, but because I recognize certain images and people, I'm able to, this one connects here, this one connects here, this one connects here. I'm able to guess at a high probability, especially if I'd spoken with you or seen you, that those connections and that relative strength that's being adjusted is you. So that's how our brains are working at, again, an incredible level. And now how that we're utilizing machines to be able to do the same thing. So extremely exciting. I hope all of you caught the simplicity of the system. Typically, when you see how simple AI is at its root, it's profound. Anything simple is always profound to me because when things are simple, you can make them more complicated and powerful. But I want you to see the underlying simplicity because that's critical. That's critical to using it and to make it more robust and complicated in your various workflows. So when you move this up real time, this machine learning as fast as possible with our computers these days, here essentially is an AI looking at a video. And you can see none of these is a guessing 100%. As this dog moves, it's going dog, 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 73%, 74%, 72%. That's essentially how AI is doing. So sometimes people tell me, how does the AI know that it's Abraham Lincoln? It doesn't. It's guessing that it's Abraham Lincoln based on whatever the training data is. Similar with auto-driving cars. Here it's just guessing over and over and over, tree, 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 tree. So that's as simple essentially as AI is working. With words, it's the same thing. Words are not very complicated. We like to think they are, but English language, for example, uses about 600,000 words. I use about maybe 30 or 40,000 during my common day, 26 letters, at least in English, and all those are representable by bits. So in the past, me as an environmental attorney, I was just using 26 letters, essentially to protect 4 letters, four codes, 4 letters in the code, those 4 amino acids. English, it's been around for a long time. Is it going to change? Well, Spanish changed, Russian, it always changes. And we've moved from more complicated language to more simple, and it'll continue to be more simple. You think about thousands and thousands of years ago, language was really complicated. Can you imagine, like, I can say the word believe now, and you know what it means, and we can just write it with, a few letters. But back in the day, you had to draw a picture of a bee and then draw a picture of a leaf. And then together, right, that was believe. And you could convey an abstract concept with those pictures. But now it's much simpler. And in the future, it'll be even more simpler. Bits are so much easier than the communication that I'm utilizing right now, because they're a lot more flexible and so forth in conveying information. So where's AI currently? Where's it going? I'm not going to talk a lot about what it's currently doing. I think many of us are familiar with it. I think more important is where it's going. What's the next big thing? It's going to keep going up, up, and up. I was born in 1969 when we put a man on the moon. Most of the everything that's happened in terms of technology and innovation has all been during my lifetime. For billions of years, certainly the hundreds of thousands of human years of history, nothing happened. And so where is this going to go? It's going to go up, up, up at an exponential rate. And we're just, as humans, we're very unfamiliar with that. We're more familiar with tens of thousands of linear change. So this is going to be very new for us to be able to adjust. We will, but it's going to be challenging. A game back when I was growing up and a game now. So what's this going to look like many years from now, and how is this going to differentiate from the real world? It's going to be fascinating. It's going to be fascinating to be a part of. Trillions of dollars, as all of you know, are going into these chips, GPUs, and all of us have heard, of course, of NVIDIA. Where are we going to get? Are we going to get to artificial general intelligence? The folks in this picture all think that that's going to happen within the next 5 to 10 years. I'm not sure, but they certainly are in a better position to guess that. Right now, we're at artificial narrow intelligence. It's understanding certain things that we train it to do, but in terms of developing its own knowledge of that cuts across different sectors, that's been more difficult. Are we at artificial general intelligence? When will we be that? And then super intelligence, which of course is exceeding all human knowledge. I think eventually we will be there. The question is when, of course. I think a big part of challenge will be the interface improvements. Right now, for example, I'm communicating to you only at 56 bits a second. It's really slow. I'm not communicating much information. And so our ability to connect with computers and each other, I think, is going to be more important in the future and more of a challenge. Will that be a brain-computer interface? I don't know what that looks like, but screens and all these devices, I think eventually will start to go away, so we can be able to share information with each other and learn information much, much faster. As all of you know, with the human brain, we're just limited in terms of how much information we can access. So being able to use these external devices to both extend our own capabilities and almost grow our capabilities, that's going to be exciting. Will we eventually merge with machine intelligence? I think it's inevitable. I don't know when that is. I think personally it's going to be very exciting. Of course, there's security and safety issues that we'll need to deal with, but the ability to access all that data will be tremendously exciting. I think this is one thing for all of you to watch is quantum artificial intelligence. I think that's heading our way. But the main focus that I really wanted to show you was agents. Within the next few years, I think all of us will have agents, the ability to use. And when I speak of agents, what an agent is and how it differentiates from large language models. Right now, large language models are giving us answers to questions. The next step will be not only answering questions, but doing things for us. And so instead of just going out and finding me the best airline ticket, it's buying the airline ticket. Instead of finding a better phone plan, it's buying the phone plan and installing it on my phone. So you can see what's going to happen with agents in the future. This is where we're going with our tools, and I would highly suggest anyone that's going into the artificial intelligence world to really focus on agents. We talked a little bit earlier in the pre-discussion about Strawberry that OpenAI is coming out with, which is around agentic reasoning. I'm going to show you how I'm developing some agentic reasoning with our system, but that's going to be crucial to really moving artificial intelligence forward. Google has announced agents today, even in the Google event. I don't know if anyone was there or saw it, but it had a research from Gemini tool. And so instead of just us typing in and Google spitting out an answer, if it sees that what we're trying to do is deep research, It's actually going to launch an agent, and that agent will go out and research different websites for us and then bring all that information together for us in a document. So again, you get the idea of what an agent does. It's not these large language models just spitting out an answer to us. It's launching out different large language models, if you will, that focus on different aspects of putting together a solution or performing an action. So that's the next really big step in AI. And everyone is going that way, everyone, as fast as possible. The neat thing is all these tools are available to you. They will be more and more available to you. You can already utilize these large language models. That's what we're doing, and that's what I'll show you. And then I just want to highlight this last one, the context windows. How much information we can upload for these models to understand is increasing, which is a powerful tool for all of us. So with AI and what we're doing, we built the world's first digital environmental assistant. What we've done is we bring in environmental data from agencies across the country, and we've trained this to understand environmental compliance and protection issues. So we take these large language models, we train them on millions and millions of environmental documents and the internet, and then essentially we create this environmental brain. And now the next step is adding agentic workflows to the brain to operate that brain better, which we've done, and then giving it certain capabilities to take actions like drafting an environmental permit or performing an environmental audit. And so that's the next step that we're working with in our system. So the idea is automating as much environmental protection as possible, really allowing an environmental professional to perform more work during their day. So that you can see this environmental department, and instead of just having one human, this human has different agents that they're employing to do different activities for them with their employees to move forward different environmental improvement strategies. So this just shows the agentic workflow, but here's essentially how the brain is working for us. So you can see I'm asking it to perform an environmental audit. And then we've got 3 different large language models. And so it's going out to the internet as well as all the environmental files that we've loaded up and helping to perform that audit for us. We also have added, and you won't see this on Google, we've added geospatial capabilities. So the metaverse is not dead. Eventually it'll come back when we get rid of these wonky goggles and figure out some way that we can better interact in this digital space. It'll still be, I think, developing with wonky goggles, but the goggles, of course, will get much better until we get perhaps a brain-computer interface, something that works a little bit better in these digital worlds. But we've gone in and given details, environmental details, to different facilities, mainly in Texas and Louisiana. But eventually we want to go and be able to do that throughout the world. So now our hope is really to create a system that's protecting the environment in real time, really to automate this thing so that we can deliver better environmental performance for the world at much, much less cost. So final section that I wanted to talk about is how can all of you use this to solve your problems? Hopefully a bunch of ideas are coming to mind right now. I think one of the basic things is read. We talked about, I know Sergio loves reading, Charlotte loves reading. You can see I love reading. Read as much as you can. And Sergio said that he's reading a lot about artificial intelligence. I would encourage all of you, if you've not, to read as much as you can about it. Please reach out to me. I took a picture of a couple books that I like, but dig in. There's so many YouTube videos. The fun thing is you can go to school for this at Stanford if you want. I took a Stanford University Natural Language Processing, which is just right on YouTube. So it's just amazing what you can learn in all the different universities and great professors you can study from and attend just through YouTube. So that I think is key. Where the development opportunities, how I look for opportunities is I look for complexity. I look for problems and I look for complexity. I look for entropy. I look for disconnections, look for things that are too tedious. Like what would I like a robot to do for me? I'll look for time savings, redundancies, ways to save time, money, and create happiness, create something that's of value. So that's how I generally think when I'm thinking through. Really, simplicity is what drives me more than anything. So that's when I'm looking for AI opportunities. And so I identify the problem. And then the next step really is to find the data that you need to solve that problem. And so there's a lot of public data out there, and you'd be amazed at the connections that can be in public data. One person, for example, found out what the wealth of India was, and how they found it out was they got geospatial data from a satellite and measured the amount of lumens, the amount of light in India at night. And from that, they could calculate essentially the wealth of India based on how many people had light. So it's very interesting how you can use data in ways that was not intended, but again, finds value. Perhaps you even ask the chatbot, hey, I'm wanting to do this. What public resources of data, maybe that are not typical, might be out there that I could utilize that would present some interesting way of approaching this problem that hasn't been done before. So, but after I've identified the data sets, then I identify the machine learning tools. And so I follow a lot of machine learning websites, news articles. You can put in Google alerts, just so you can stay abreast of this, because it's changing all the time. Every day, almost, there's a new tool that's coming about. So if you say that today something is impossible, tomorrow don't say that. It's a bad mentality. You almost have to get into a mentality of every day, what you thought was impossible could be possible today. And look for the opportunity, if it's not, to make it so. Brainstorming with other users, taking a look at what's happening in the medical field, what's the financial field. Those are the fields that really are beginning to use AI a lot. So look at how those sectors that have so much money and resources associated with it, the tools that they're developing, how they're using it, and then how you can use it in the area where you are a subject matter. I think subject matter experts are actually going to have higher value than people that know artificial intelligence. And the reason is these tools will become available to all of us, and it'll be very simple and easy to use. What Google and the others won't be able to do right away is to be able to implement those into the different silos of interest or those different subject matters. And so those areas where your knowledge of subject matter is high, this is the time to develop AI and to develop agents. I think the market for agents is going to close. I think eventually, I think it's maybe about 1 to 2 years. After that, agents will be developing agents. And agents, remember, an agent that does cooking can do brain surgery in terms of they can share the information with each other. So they don't have to go through 10 years worth of school like you and I. So again, I think that opportunity really for developing subject matter agents, I think is one in the near term. So after you develop those tools, developing a coding team, there's a lot of functions now for no code tools to develop, creating websites, creating other apps, creating just an API that other people's electronic tools can use to solve a problem. A lot of different opportunities out there. I don't know how to code, never know how to code. I wouldn't waste the time learning how to code. There's plenty of people that either know out there or computers are being able to do it better for us anyway. So that would be my thought on that. The economy, the impacts, of course, are just in the trillions. It's very exciting, and it's just an issue of time of how quickly we get there. This relationship that we're going to develop, this is the one time I think in human history that this opportunity of is going to be here. Eventually, once the machines are more intelligent than we are, I think our value will be more in sentience, spirituality, those other things that I don't think machines will be able to mimic. And so I think intelligence, I already don't know what 135 times 23 is, and a simple calculator can do that. And I think that'll be the case for computing, doing other things. So using AI requires a lot of intellectual humility. You just got to realize that you aren't that smart. And these systems are going to be much smarter than us in the future, but it's how we employ them, how we use the creativity, the imagination, the other gifts that we've been given to really augment these tools and to harness them into things that can better the world around us. So with that, I'm going to go ahead. You can see, I've given a couple of tools. There's off the tool shelves that you can use. And I really would, in the near term, focus on agents for opportunities. Each of us will have our own that we'll use for doing different tasks throughout the day. And also we'll be developing them, of course, for business.